Aloha champions, and welcome back to this Thursday science video. I know on Tuesday I hinted that this might be a type of energy that is very useful for us here in Arizona. And yes, we do use hydroelectric energy here in Arizona. We have a lot of hydroelectric dams in Arizona, but it is not the most useful for us. That comes next Tuesday when we talk about solar energy. But hydroelectric energy is still a wonderful source of renewable energy, and it serves multiple purposes, especially for us desert dwellers here. We often build dams and reservoirs blocking up parts of a river to hold on to water that we release in controlled intervals from one hydroelectric dam to the next to power and generate energy, but also to store water that we can use to use on our crops, use for ourselves, use in our households without using all of our water in one go and not having any water to drink or to water our fields with without this. So hydroelectric energy is a very good way for us to power certain aspects of our life, but it also comes with some costs, like those non-renewable forces. So, big question for today that we want to answer is, how do people use moving water as a source of energy? And our vocabulary term is hydroelectric power, which is electricity generated by the energy in moving water, usually through a dam. So, we'll learn more about hydroelectric energy and how this helps us to make energy. Like wind energy, water energy has been harnessed for thousands of years. It has always been used to produce mechanical energy, the energy of motion, kinetic energy, moving and moving and moving and rotating and rotating and rotating. Well, that rotational power we use in generators, right? We generate by rotating and rotating and rotating, so electric energy, a good transference of that. But only recently in human history has moving water been used to produce electrical energy, hydroelectric power, which is an important renewable energy resource. Old water mills converted the energy of moving water into mechanical energy. A modern hydroelectric power turbine does the same thing, spinning and spinning and spinning and spinning. Hydroelectric power is more predictable than wind power because water can be contained or controlled. A hydroelectric power plant involves a dam that creates a large reservoir. The reservoir provides a steady supply of water for the turbines. Things to consider about hydroelectric power. A hydroelectric dam can be set up where there's a lot of water uphill from an area where it can flow down safely. It is most practical to set up a dam where flowing water can steadily refill a reservoir. This is why hydroelectric dams are usually built on large rivers. So, like the Colorado River, one of the largest rivers in the western half of the United States. We have the Hoover Dam, which supplies a lot of energy for Las Vegas. Well, it's set up on a big river. Okay? Engineers must consider the source of the river water. The water cycle brings water onto land in the form of precipitation that falls when clouds cool and condense. All this wonderful rain and sprinkling, drizzling that we've been having this week is all forms of precipitation. And here in Arizona, we don't get precipitation as much as other places, but we still get enough to try to refill our reservoirs, even though they're at an all-time low right now. But that's beside the point. When rain falls, it flows downhill and builds up into streams. The same occurs when snow and ice melt. But some of the flow from melting ice can be from precipitation that fell long ago and accumulated over a very long time. A glacier that is slowly melting and feeding water into a river may eventually melt away completely. So if it's not being replenished often, but it is a glacier that was built thousands and 10,000s of years ago by snow compacting on snow, compacting on snow, freezing into one solid block of ice, that may eventually not last forever. The river could eventually shrink to a trickle or vanish completely. A more reliable river over the long term might be one that receives water from rainfall and snow that melts each spring and summer. Either way, engineers must consider data about the weather and climate of a given area. Hydroelectric power depends on large amounts of water spinning turbines to generate enough electricity to make the project cost-effective. Blocking a river so that a large reservoir will form behind the dam might be necessary to make the project cost-effective, but this takes a lot of time, money, and careful planning. If something is cost-effective, whether it's a dam or anything you need to do, is describing the balance of factors when benefits outweigh costs. Does the benefit I get from owning this thing outweigh the cost that it takes to build it? Okay? And when you're thinking about your own personal budgets, if you earn an allowance or want to save up to spend money on something, will what you get out of it be worth more than the amount of money you spent on it? Okay? However, there are some costs and hazards when it comes to hydroelectric dams and getting hydroelectric power. While hydroelectric power is very clean, it's just water and we can reuse that water to drink or water our fields, it is not without the cost to the environment. Blocking up a river to produce a large reservoir floods the area behind the dam, and often you have dams that are built up near where old towns used to be, and you'll flood over those old towns because it was more beneficial to people elsewhere to use that energy than the people who were living there. This destroys some habitats. Dams can also interfere with fish, such as salmon. Salmon are born in rivers and migrate to the sea. Then they return to the streams where they hatch to reproduce. A dam also alters the river downstream. The flow of the river may be slowed and its depth reduced. Organisms that once had a fast-moving, wide, deep river might have something slower and narrower to swim through than before, or the river may change dramatically from one week to the next as the dam controls the flow of the water to meet the region's electrical needs. Okay, so here's a picture of a hydroelectric dam. You have your reservoir, the big lake of water, and you have an intake valve that is controlled mechanically or electronically to open and let water flow through. That water flows through and spins a turbine. Spinning turbines are what give us energy, whether it's non-renewable or renewable. Just spin those turbines. Spin it, spin it, spin it. And that turns into our power, which goes against our power lines. And then we release the rest back into the river to go further down. We have fish ladders that can be built to help migrating salmon move up or down the dammed parts of the river, and there are also newer dam and turbine designs that are fish friendly. There's wonderful videos of dam workers who take the fish out of the stream, put them in a chute, and the chute launches them up further the river. It's always fun. These allow fish to pass through with less interference. However, a dam's overall disturbance to river environments is hard to completely overcome. Dams are also vulnerable to accidents. If a river or reservoir receives an unusually large amount of water from high rainfall, the pressure of its concrete and steel walls may be too great. This occurred in Laos in 2018 when a multi-billion-dollar dam that was still under construction collapsed after heavy rains. A large amount of water suddenly spilled through the dam and flooded the landscape. I might remember a few years ago, might be 5 years ago, or at some point, Tempe Town Lake, which has a dam to that's not hydroelectric, but to just contain water for Tempe Town Lake. That whole dam erupted, and Tempe Town Lake was drained, and all the water flooded out after we had 1 or 2 days of heavy rainfall that gave us more water than normally we have in that area. Okay, so hydroelectric power and tides. Water moved downhill by gravity is one renewable resource that can be harnessed. So rivers going downhill, we can dam up, put into reservoir, and control the flow of water to spin those turbines to give us energy. But water moved by tides is another. So tides are your ocean waves coming in and going out. Well, tides are caused by gravity too, but instead of pulling water downhill, tides pull ocean water across Earth's surface. Tides result from forces of gravity between the moon and the sun and Earth's water. To harness tidal power, turbines can be placed in areas where tides produce a very strong current. A shallow span of ocean is often the best place because tides tend to move swiftly there. A dam-like structure can also be installed in an area with strong tides. As the tide comes in, the turbines spin one way. When the tide goes out, hours later, the turbine spins the other way, producing electricity. Hydroelectric power that uses tidal movement is practical only in some areas that have coastline and experience tides, because tidal movement changes speed and can slow to a standstill. An electric grid is unlikely to rely on tidal hydroelectric power alone. So if it's tidal hydroelectric, that's supplementary energy. If it's hydroelectric like the Hoover Dam powering Las Vegas, that is pretty much the only energy source that they need. So in our Tuesday video next week, we'll be talking about solar energy, a source of energy that we are trying to harness our best here in Arizona, because we do have a lot of sunlight with over 320 days a year of just wonderful sunlight, very little cloud cover. We're trying to utilize this, but we'll find out more on Tuesday. For today, you've got 5 to 10 questions to answer about hydroelectric energy, so take your time, answer those questions, stay awesome, and I will talk to you real soon.